Hi guys, welcome back. This is video 5 of the Unreal Engine 4 inventory system. This video we're going to look at setting up some functionality on the player character to be able to trace for nearby objects and then add them to the inventory itself. So we're going to just start by looking at the first person character. And what we need to do is, over on the left hand side, just create a new function. And this function is going to be called trace for item. And what we're going to do in this trace for item, we're going to use a function, a built-in function called a line trace by channel. Now what the line trace by channel does is you have a specified start vector and a specified end vector, two locations in 3D space. And between the start and end we draw an imaginary line, and what we can do with this imaginary line is we can check what objects we hit with the line that we created, and those out hit results we can use to do all sorts of different things. So we're going to start by setting up the line trace itself. What we're going to do is we're going to create the line trace to basically fire an invisible line from the first person camera down the x-axis. So we're going to specify probably a distance of about 2 meters or so. So if we compile that, let's just jump back into trace for item. We're going to grab the first person camera, and we want to get the world location of this component. Okay, so obviously the player character is going to be moved around by the player, so we need to know where in the world the first person camera actually is. Now to specify the end vector, the end position, we need to firstly get the forward vector of the camera itself. So get forward vector. Now forward vector in Unreal Engine 4 is the x-axis. So in other software it usually is the y or the z, depending on whether you're using a y up or z up system. For Unreal Engine it's the red or the x-axis, which is your front vector. So the front vector is the x. We want to multiply this vector by a float. Now the float is going to be the trace distance itself. So how far from the camera do we want to be able to scan in front of ourselves? So we're going to create a new variable which will hold this. Got two though. So this one is going to be called trace distance, and it's going to be a float. So compile and set the default value to about 250. And wire that trace distance into the multiply node. Now that we've got that result there, we need to grab from the original world location a vector plus vector operand, because we want to add the result of this multiplication to the original start position, and that will give us our end position. In terms of the line trace by channel output, what we're going to do is we're going to get the out hit and we're going to break the hit result. And this is going to show us a whole bunch of different things that we can get information about. So we can get blocking hits, overlaps, distance, we can get the normals, we can get hit actors, face index, etc., etc. Now what we're interested in mostly is the hit actor, because we're looking for an actor to pick up. So if we hit the actor, we want to store a variable, store a reference to it within a variable. Make sure that you use the global variable and not the local variable, because we need to access this within other functions. So just call this new variable hit actor. Now we only want to set this if we actually execute, if once we executed the line trace, if we actually hit anything. So the condition we're going to set to true, and we're just going to wire out the true outcome from the branch to the set actor. For the false, we're also going to set the hit actor, but we're not actually going to wire anything in. So if we press to trace for an object and we didn't hit anything, then we're just going to set the hit actor variable to store a null value. So just compile that. And in fact, before we leave, we'll set the draw debug type to for duration, just so that whilst we're testing, we can kind of draw visible lines to see where the line trace has actually worked. So we're going to create another new function, which we're going to call add to inventory, or add to inv. Now, we mentioned in a previous video that we can use cast operations to check if an object is of the type that we are expecting. In this case, we're going to cast to pickup BP because we want to check if the actor we hit is of the type pickup BP. If it is, we're going to promote it to its own variable, which we'll call hit pickup, to differentiate it from the hit actor. So before we get into the logic for adding to the array, we need to check whether or not this hit pickup is stackable or not. So from the hit pickup, we're going to get the item data associated with that pickup. And we're going to break that item data to see the properties within. Now the property we're interested in is the can stack option. We're going to run this boolean out to a branch. And the idea with this being that if we feed in this can stack into this branch and it outcomes true, then we're going to have a whole bunch of logic up here which will handle stackable objects. And if it's false, we're just going to add the object directly to the array. So we're going to start with just looking at non-stackable objects. Firstly, we need to get the hit pickup. And we're going to get the item data again. Now what we're going to do here is we're going to split the struct pin so that we can get the information. To be able to add to the array, we need to create a new entry based on the item data that we are getting from the pickup itself. So just to the right, we're going to right click and we're going to say make item data to make a new structure. And this is just going to be a simple matter of wiring up the corresponding variables across, because we want to feed in all of the appropriate information. The only one that we're not putting in is the item data quantity, because we want to increase the quantity when we pick up the item. So from hit pickup, we're going to get the amount to add, and from the item data quantity, we're going to add the amount to add and set that to the quantity. Now before we can add this to the inventory, we need to be able to actually get a reference to it. So we're just going to temporarily go back to the event graph and just have a look at the begin play event for the first person character. After we've set the inventory widget, we're going to do a cast to my game instance, feeding in a get game instance function. And from the get game instance, we're going to promote to a variable. And this variable is just going to be called game instance. Compile, and then jump back into your add to inventory. Now that we've got the reference to the inventory, or the game instance, we can get the game instance, we can get the inventory. To add an object to the array is very simple. All we're going to do from the inventory is just call an add operand. all you need to specify is the execution and the item to be added to the array. Now, if you remember back to the previous video, I mentioned that we needed to refresh the inventory whenever we picked up an item. In our character, after we've picked up this item, we need to make sure that we perform that refresh inventory event. So we're going to grab a reference to our inventory widget, which we saved over in our variables, and we're going to call the refresh inventory function. That will allow the inventory widget blueprint to refresh and re-loop through the inventory and apply the correct item information. The last thing to do is simply to destroy actor, and this will get rid of the pickup from the game and from memory. Okay, so let's compile that. Let's jump back into the event graph quickly, and we need to specify an input which will allow us to pick up our objects. So just find some free space. I'm just going to right click and just type in E key because I want to use the letter E. And from pressed, we're just going to say trace for item to call that function first, and then call our add to inventory. So if you compile that, let's just jump into the editor again, and we'll set up another pickup so that we have two pickups. One which is intended to be stackable, the ammo, and one which is not. If we test and play this now, what we should see is that the ammo pickup will not be removed from the game and will not be added to the inventory. That's because we haven't set up the stackable object logic. For the health pack, if we press E, you can see that the object disappears. We can press the letter I on our keyboard and we can get the health pack button. Now there is one error in that the number is not pulling through. So we'll have to have a look and see what is going on there. So let's have a look at the set amount text. So if you go to the graph, set amount text, current stack is equal to 0. If that's true, that's false, current stack. Okay, let's just have a look in the inventory widget, quantity. That should be set in current stack. Okay, let's just have a look back in the pickup. Okay, so the mistake that we've made here is that we haven't actually set the amount to add variable, so nothing was happening. So what we need to do is, in the health pack, we need to set our amount to add, and we're going to add 1. And for the ammo pack, we're going to add 20. The amount to use, we're actually going to set to 0 because the ammo is going to be a special case for the amount to use, but the amount to add is going to be 20. Break that link. Just get rid of that pin. Okay then, so if we compile, let's just give that another test. So when we go to pick up the health pack item, you can press E and press I, and we have the correct title and the correct amount. In the next video, we'll have a look at setting up the logic for stackable items.